This is example number 3 of our lesson on equation applications. So our question says the value in dollars of a painting can be calculated using the formula V at T equals 1,200 times 1.05 to the power of T, where T is the time in years since the painting was purchased. So it didn't specify the V, but the V stands for the value. How long will it take for the value of the painting to double? Round your final answer to 2 decimal places. Okay, so I have an equation. So V at T equals 1,200 times 1.05 to the power of T. Since the T is in the exponent, this is an exponential function. It tells me that T is the time in years, and V, it doesn't explicitly state this, but V is the value. And it wants to know how long does it take for the value of the painting to double. So it didn't actually give me a number to put in for the value. It just says how long does it take to double. So something that I might want to know is how much was the painting worth at the beginning, so then I can double it and then go from there. So first thing I'm going to do is try to calculate what the starting value is. So I'm going to try to find our start value. Now, when would that starting value have happened? It would be when we purchased the painting. So I would have purchased the painting in year 0. So at T equals 0. Anytime you're looking for the value at the start, we always want to put in 0. So that means the value at 0 is 1,200 times 1.05 to the power of 0. Now anything to the power of 0 is 1, and then 1 times 1,200 is 1,200. You could also just type that in on your calculator. So what that tells me is the starting value of the painting is $1,200. They purchased it for $1,200. So why do I want to know that? Well, we want to know how long it takes for the painting to double in value. So I'm going to calculate what double the value is. So right now, they bought the painting for $1,200. And it is now worth double. Double means times 2. So we want to know, when is it worth $2,400? So what I'm going to do is put this in for V, for my value. So I'm going to take my equation, which is V at T equals 1,200 times 1.05 to the power of T. And everywhere I see V, I'm going to put in $2,400, right? That is double its original value. So that equals 1,200 times 1.05 to the power of T. Now, it is really tempting to multiply these two numbers together, so the 1,200 and the 1.05. But the 1.05 has an exponent. An order of operations says that you need to do your exponents before you're allowed to multiply. So I cannot multiply these together because of the exponent and because of order of operations. So my goal is to solve for T. So I want to try to get the T by itself. I only have one T in the entire equation. So I think we're going to try to do a little rearranging to isolate for T. So when you are rearranging, we do BEDMAS in reverse, or order of operations in reverse, meaning the first thing we do is any addition or subtraction. I do not have any addition or subtraction. Then I would move on to multiplication and division. I definitely have some multiplication here. So I'm going to cancel out that multiply by 1,200 by dividing both sides by 1,200. So 2,400 divided by 1,200 is 2, right? It was double the starting value. So when you divide the double value by the starting value, it should end up being a 2. And that is 1.05 to the power of t. I don't need the bracket anymore. The bracket was just there to show multiplication. Okay, so how do I solve for t when t is in the exponent? Well, I want to try to find a way to get rid of that base. So I need to try to figure out how to get rid of a base of 1.05. So the inverse of an exponent with a base of 1.05 is to do a log with a base of 1.05. So we're going to do log 1.05 of 2, and that should equal t. Now, did the question say that it was okay to use a decimal? Yes, it did. It said round your final answer to 2 decimal places. So my calculator cannot do log with a base of 1.05. So what I have to do to evaluate this is use the change of base formula. So that's where you do either ln or log, because that's what every calculator knows how to do. I like ln, so I'm going to do ln of the argument 2 divided by ln of my old base, 1.05. If you didn't want to use ln, you could do the same thing, but with log 2 divided by log of 1.05. You can actually do any base that you want, but ln and log are the ones that my calculator knows how to do. So my calculator, I have to put the argument in first and then press ln. If you have a calculator where you see what you type on the screen, right, where the word ln actually shows up, you would do ln first and then the number. So I would have to do 2 ln divided by 1.05 ln equals, and I got 14.20669908, or approximately 14.20. The next digit is a 6, so that's going to push that up to 14.21. Now, if I tried doing the same thing but using log instead of ln, if I did log of 2 divided by log of 1.05, you will notice I get the exact same answer I had before, right? So it doesn't really matter whether you use ln or whether you use log. So the question was, how long will it take for the value of the painting to double? It will take approximately 14.21 years. So therefore, it will take approximately 14.21 years to double in value. Okay, so that's the end of our equation application practice. There are some equation application questions in your textbook on page 110, 190, 353, and 392. There is also some additional equation solving practice if you're looking for a little bit of extra practice to do. My recommendation is maybe to save this for after you write your unit test. Okay, so have a great rest of your day.